Precalc 02, operations with complex numbers. So complex numbers are numbers in the form a plus bi, where a is our real part, and bi, remember I is the I for imaginary numbers, so this would be the imaginary part. So they have a real and an imaginary component, and we always write that real part first. So first we're going to look at powers of I. So if I is equivalent to the square root of -1, that's by definition. So this one we just call I. And then we want to think about what happens when we square it. So if I take the square root of -1 and I square that, because I'm trying to find I squared, the square and the root would cancel. We would just be left with -1. So I is just I squared is -1. And this should be review. When we look at third power is I times an I squared. So we know I is just I, and then I squared is -1. So that's why we have I times -1 over here. So that's going to multiply and make -I. So I is I squared is -1, I cubed is -I, and then now we're going to look at fourth power. So fourth power would be an I squared times an I squared. We've already decided that I squared is -1. So -1 times another -1 is a positive 1. So then we're going to look at what happens when we do some higher powers. So how about if we have I to the 5th? So I to the 5th would be one more factor of I times I to the 4th, which is I times I to the 4th is just 1. So this is going to be I. Now let's look at I to the 6th power. So 6th power would be an I squared times an I to the 4th. I squared we decided already was -1. I to the 4th is 1. So this is going to be -1. I to the 7th, we're going to do two more, 7th and 8th. This one would be I cubed times I to the 4th, right? 3 and 4 make 7. I cubed is -I, and I to the 4th is 1. So this is -I. And then I to the 8th is I to the 4th times another I to the 4th, which is a 1 times a 1, which is just 1. So we talk about these powers of I being cyclical. So cyclical, I mean like a cycle, and I spelled that wrong. Let's fix that. So hopefully you can see how those powers cycle through. Cyclical. So if I scroll back up again, kind of to get the full effect, we start out with I, -1, -I, 1. I, -1, -I, 1. And we would keep cycling through those powers because we keep adding just one more factor of I, which just rolls us right through that all over again. So we're looking at some kind of different powers on this page. The first one is 25th, and really how we're going to do the 25th power, we could do anything. We can always look at that multiple of 4. Anytime I have I to a multiple of 4, and 24 is a multiple of 4, we know that that's just going to be a 1, right? Because I could make this I to the 4th times I to the 4th times I to the 4th. I can do that. 4 divides into 24 evenly. So this is just going to be a 1 times. And then if I have 25 factors total, it should be times another I. So 1 times I, which is just I. Another way that teachers often show students is to look at how when I divide 25 by 4, my answer is 6. So I'd have 6 groups of 4. That would mean 6 factors of I to the 4th, which is just 1. And then the leftover, this is going to be my leftover factors of I. And this is going to be equivalent to our answer. So I to the 25th would equal I to this power, which is just I. And that will always work. You can always divide by 4, use that remainder as your exponent. So let's look at negative powers. If I have the -12th here, then what I would do is make that 1 over I to the 12th. And then I recognize right away that 12 is a multiple of 4. So I to the 4th, I to the 4th, I to the 4th, that'd be 1 times 1 times 1. It's just 1. Anytime I have a multiple of 4, it's just 1. So 1 over 1, which equals 1. So let's do just a couple extras, maybe another higher power. Let's try I to the, let's do I to the 54th. So I'm going to use my division trick, 54 divided by 4. Let's see, this would be 1, 4, let's see, 14. 4 goes into 14 how many times? 3. 12. 2 is left over. So that means that this remainder is going to become my exponent. It's going to become the exponent for I. So then I to the 54th power is the same thing as I squared, and then I should know that I squared is a negative 1. So that division trick is probably going to be the easiest way for most people to do this. When I'm simplifying, I'm basically just adding my like terms. So for the first one, 4 and negative 3 would make a 1. Negative 1i and 5i is plus 4i. The second one, I would need to distribute the negative sign. And so I'd have 8 minus 5i minus 4 plus 2i. So let's put our real parts together. 8 minus 4 is 4. And then the imaginary parts, negative 5 and 2 would be minus 3i. On the next two, the parentheses are right up next to each other, so we can tell we're not adding and subtracting now, we're just multiplying. So 2 times 6, 2 times 7i, so plus 14i, minus 18i. It's pretty much like what we've already done, except we have a trick. When I multiply negative 3 and 7i, I get a minus 21i squared. And I have to remember that I squared equals negative 1. So we're always going to remember that and substitute that. So now I have 12 plus 14i minus 18i. I should have put those together, but I'll do it on the next step. I kind of forgot. And now this will be a minus 21 times negative 1. So 12, I'm going to go ahead and combine now, minus 4i plus 21. So really all it does is it flips that sign. Instead of a minus 21i squared, now we have a plus 21. And then I can put those real numbers together. The 12 and the 21 would make a 33 minus 4i. On the next one, I have 3 minus 2i squared. I could write out both factors if I needed to look at them, or you can just expand it. So this would be 9 minus 6i minus another 6i. Remember, the middle term's always doubled. And then plus 4i squared. Remember, we said multiplying by that negative 1 just flips the sign. So I'll have 9 minus 12i minus 4. And then I put the 9 and the negative 4 together, so 5 minus 12i. This should really be review. We did all of this last year in Algebra 1, or in Algebra 2. On 4, to simplify, I want to multiply by the conjugate. So the conjugate is if I take my denominator and I keep the 1 and I keep the 2i, but I'm going to switch the sign. So I'm going to multiply by 1 minus 2i over 1 minus 2i. So now in my numerator, I have 12 minus 24i plus 3i minus 6i squared. Now in my denominator, I have a sum and difference here, right? So let's just remember back or think back to when I had like x minus 2 times x plus 2. We know that that always yield what x squared minus 4, right? That's what that would yield. So I would do the x squared, the plus 2x, the minus 2x, the middle terms always cancel. There's always a minus sign between them. They're squared. So I'm going to use that to just write 1 minus 4i squared. So we always want to look for that pattern and save ourselves the time. So in my numerator now, I can simplify 12 minus 21i. And then remember, if I have minus 6i squared, my I squared is equal to a negative 1. So this is going to change it to a plus 6. In my denominator, I'm going to do the negative 1 for I squared trick as well. So we have 1 plus 4. And now we're up to, let's see, 18 minus 21i over 5. And then I want to write this in complex number form, so my real part is going to be 18/5, so I'm kind of splitting it apart, minus 21/5 times I. Last year I let you leave it as a big fraction. Now we're going to split that up this year. So for our last page, we are finding values of x and y to make the equation true. We're going to set the real parts equal. And we're going to set the coefficients of the imaginary parts equal. So my 3 is going to equal my y, and my 2 is going to equal my x plus 4. So 3 is going to equal y, and 2 equals x plus 4. So it looks like I need to solve for x here, subtract 4 on both sides. Negative 2 is equal to x. So then I could write that xy is equal to negative 2, 3. So this has been just a quick review of some things about imaginary numbers. Please do the homework assignment for this. As always, check your answers and get help if you need to.